My name's John. This is the video report of our ladder climbing robot. The aim of this project was to design a robot that was fully autonomous and able to climb the ladder seen here from the fourth rung all the way up to the top rung, touching all the rungs on the way, and optionally for extra credit, able to go down without falling. So it has to climb every rung up and climb every rung down. We opted to just climb up every rung, and we used a rail essentially right there. We used gears on the sides of the ladder that would allow it to easily go up and down the ladder itself. I considered wheels, but that wouldn't allow enough space, so we used gears instead to ride between the rails and the space on the ladder. Initially, the design we had was just two large cylinders. They're double actuated off of a double DCV, and the way it was set up was it would let one side climb, and there's also little cylinders on the bottom. They're single actuated cylinders that would push the shaft out, because when it's initially on the ladder itself, they're not 90 degrees, they're a little bit in, and that was allowed to allow it to climb the ladder itself. The little cylinders would let it push out so it could bypass the rungs as it was going up. Materials used in this project were two double actuated cylinders, two single actuated cylinders, two small gears, some shafts, some metal, the ladder itself, two DCVs, two single control valves, four one-way control valves for throttling the speed of the cylinder extending and retracting, a push button, easy port connected to the computer for automated operation, and a power supply. You can see here that was the intended operation of that was basically the bare bones stripped down intended operation, where one side would extend and grab and the other would allow it to bypass so it wouldn't get caught. You can see here on the control diagram that when you press the start button, it would let the small cylinder extend out to and then it lets the other one, the large one, extend, and then they both drop out, so it would both drop and retract so it could grab the rung. We had it set up using a digital latch, so when you press the power, it would keep the power on, and every actuator would activate in sequence, and when it hit 2K7, it would reset the latch so it could do both sides over again, and until it hit the count, it would just keep going. And that count was 3, so you can see here that it has the intended operation using push buttons initially, and that was what I was trying to do at the very beginning. Unfortunately, when we added more things on, it wouldn't work as intended. Because you can see there, it's kind of wobbly, it's not stable. It moves around. You can see the claw itself. The professor gave us a little bit of consideration since we couldn't get this done on the deadline. You can see problems encountered. Maybe the claws were too long, it wasn't supported enough on the bottom, for some reason the actuator on the right wouldn't throttle even though we replaced some control valves. Perhaps it was held too closely to the ladder itself. The bottom portion wasn't supported, so it allowed it to move around and allowed it to get messed up, essentially. Maybe perhaps we could have done a different design, single cylinders, maybe 3D printed parts. That's something we could have done. Thank you for watching.